Hi everyone, so let's talk about the balance of BST. So BST represents binary search tree, okay? So given a root of a BST, you have to return a balanced BST, right? So the given BST, it shouldn't be balanced. Just for a tree, right? So somehow you have to return a balanced one, right? So how do you actually do it? Let me just quickly give you the hints. So if you are given the root like this, right, definitely just go on the right. But how about if you're given a root, you have the left and right children, right? So there's a way to actually sort this. Be honest. So you can use in an in-order traversal. So for this one in-order traversal, it's going to be 1, 2, 3, right? And this is a list, right? Then at the end, after we get a list, right, we can start building the tree based on the list, right? We can have a I and j pointer, and then for every single time we find the middle one. So I'm going to say k in this point, and k represent the middle point, right? So I will have to say, okay, this is going to be my root, right? And then and then for using a recursion solution, so root of left is going to starting from I to k minus 1, right? And then root out right, right? This is left. I'm just making sure you know. Left and right. And for the right, I'm going to say it's going to be what? K plus 1, right? To j. So j represents the index, so it's going to be the list of size minus 1. And this is pretty much the solution. So let me start coding. So here's it. So list. So I'm going to store the tree node into the list. So here is it. Sorry. Yeah, so the base case is going to check if the root is actually equal to null. If that is true, then I will return null. Then I'm going to just traverse the entire tree. So it's going to be in order using both. Reorder. I'm going to say root. And then if root is actually equal to null, I'm just going to ignore. Okay. Now I'm going to traverse on my left. In order root on left. And then after that, and then I will hit at some point, which is a leaf, right? So list.add, I'm going to add a root, which is tree node, right? So now I need to go on my right. Okay, so this is pretty much it, right? So I'm going to call this function. Now I need to also build a new tree, right? So I'm going to say public, and you need to return the tree node, right? This is because the function want you to return the tree node, right? So I'm going to say build BST. All right. So I'm passing the what? Passing to pointer, which is I and j. So you can say low and high. So what do you actually need to pass in? So return build BST. So I'm going to pass in the 0 to list size minus 1, right? The index, right? And I also forgot to initialize my list, right? All right, now here's pretty much the solution. So the base case is going to be this. If a low greater than high, I'm going to return null. Right, so this is going to be a base case. So making sure you know. All right, so I need to find out my middle point, which is going to be mid. In this case, so I'm going to say high minus low divided by 2, so you get a middle value. And I know that the index doesn't start from negative, so you can say low plus high divided by 2, right? That's also correct, but I like this habit. This is because if I traversing a list which has a negative value, it doesn't matter if it's a tree or not, right? If I have a negative value and I want to find out the middle one, and which is, this one should be a base, right? So just making sure, right? Okay. So now I need to create a tree node. I'm going to call it root. So I can actually just grab the middle one to be my current root. So my current root should be 2 in this one. So for example, 1, 2, 3, 4, right? The middle one should be what? 0 plus 4 divided by 2, so it should be 3. 3 be the middle, right? Should be the root, right? So I will say, I get mid. At least I get mid. And then root of that is going to be equal. I need to generate another root, right? So I'm going to call double function. Sorry, build BST. Double function. And then it's going to be starting from low to mid minus 1. And it's going to be exactly the same idea. Build BST. It's going to be mid plus 1 to high. And at the end, you will just return the root, right? So this is actually a recursion solution. And here's the submission, right? So let's talk about time and space. So I need a space for this one, right? This is all of n. So every single node into the list, all of n. And I need to traverse the entire tree, right? This is all of n. And this is pretty much it. So it is all of n for time and space. And definitely you have to traverse all of n again into the list. Then, I mean, you have to build a tree as well. So it's going to be all of n. And this is pretty much the solution. And I'll see you next time. Bye.